f of x equals c times b to the power rx, and the exponential form that you see all the time, y equals e to the power x. That means the c equals 1, the r equals 1, and the b equals e, which is the natural number. And natural number e is about 2.718 and so forth. So the typical graph, the decreasing graph, increasing graph, I did it backward, right? So b is between 0 and 1, the graph is decreasing. b greater than 1, which is the base, the graph is increasing. Both of them crossing the y-axis at the same point, 0, 1. And I highlight this as this is the b value, which is the base that raised to the power rx. X is the input. And then the application that you saw in the section 5.1 would be the application about the interest, either the compound interest. A equals P multiplied by 1 plus R divided by N to the power NT, where A is the balance or the future value, P is a deposit, R is the interest rate per year or the annual interest rate, N is the number of the compounding. The N, you have to look at the key terms such as quarterly, annually, or weekly, something like that. Okay, this key term will tell you what are the value for the N. Quarterly, N equals 4. Annually, N equals 1. Weekly would be 52 because 52 weeks in 1 year, something like that. And T would be the unit in years. Okay, and the other one is called compound continuously. The formula is A equals P multiplied by E to the power RT. No N in this formula because it keeps compounded like back to back, back to back. So you cannot count how many times in 1 year. And then this, as you see, the formula involving the base E. Okay, and variety of the examples that you will see in the notes 5.1. And then the other example involving the form as the n equals the a times 1 minus e to the negative some number t. So that's another form of the formula that you saw in the notes 5.1. All of them, they are the exponential function, but just different applications. So that's 5.1. And then for 5.2, 5.2 is about the log function. So you see this. So number 2 is the algebra of the natural log function. Okay, the log function is the inverse. I put a note here. It is an inverse of exponential function. With the relationship, the inverse, if you have y equals e to the power x, the inverse is going to be in the form of x equals e to the power y. So the log as in the exponential form at x equals e to the power y is equivalent to, I put if and only if or if here as y equals the log or ln. Ln means the natural log or the log base e. E is the natural number of the quantity x. So that's why it's called the natural log function. Okay, so we talk about y equals the natural log of the x, and x is the input. And then the properties that you see all the time, and you're gonna use more for the later part of chapter 5. I put a note here as the properties of the log function. The first one is called the product. That means the natural log of the product of the two quantity, you can rewrite it as the sum of those two logs. You can work back and forth. So maybe you work on the log of the product and write it as a sum, or work on the sum and rewrite it back as the log of the product. The first one is called the product property. And the second one is called log of the quotient, m over n is natural log of the m minus natural log of the n. This one is called log the quotient property, because you start with the quotient and take the log on top of it. And the last one is called the power property. When you have log of the m to the power r, the power r is the coefficient or the constant multiple to the log of the m. Okay, this one is called the power property. So three main properties for the property of the natural logarithms, and the rest of them, they are the properties that you can use in different occasions. For example, number 4, so the log of the m equals log of the n. As you see, the m and n, they are the expression behind the natural log with this equivalent way. So we can refer to like m equals the quantity n. We use this when you solve the log equation. Log equation means the equation that has log expression involving in one side or both sides of the equation. And then the number 5 and number 6, I put here 5 and 6, they are based on the same concept. The log 1 equals 0 and log e equals 1. Log 1 equals 0 from the relationship that y equals log x is x equals e to the power y. It's the same as this is log base e of the value 1 equals 0. And this can be rewritten as the exponential form as e to the power 0 equals 1. And that's true. For the second case, this is log base e of the e equals 1. So we can rewrite as the exponential as e to the power first equals e. As you see the relationship of the numbers here, number e raised to the power 0 equals 1. Number e raised to the power 1 equals e. All right, that's 5 and 6. And the other group, 7 and 8, 7 and 8, 7 and 8, they are in the same category or the same concept. E to the natural log x equals x. Log of e to the x is x. These two, they are composite of the function and its inverse. We call the inverse of exponential is the log function. So e to the power log is x, or log of the e is x. You can see that e and log, they cancel each other out. So these two, they are called the use of the cancellation law. Okay, and these two by definition. Okay, and these three, the property that you're gonna use more than anything else: product, quotient, and power. So this is the quick summary for the 5.2.